So question 119, it's binomial expansion. So the first three terms in ascending powers of x in the expansion of this thing here. So I'm using the binomial expansion straightforwardly. I've already got a 1 here. I don't need to do any factorizing out of any factors or anything. So it's 1 plus n times x plus n minus 1 x squared over 2 factorial. So those are the first three terms. Simplifying those gives me that. So that's the first three terms. State the set of values of x for which the expansion is valid. So it's valid for the modulus of this thing being less than 1. So that means that the modulus of x has got to be less than a third. So now we've got to find a suitable value of x to find an approximation for 0.91 to the power 1.5 or 3 over 2. So 0.91, that means that we've got to make 1 plus 3x equal to 0.91. And that means that x has got to be minus 0.03, which is a valid value because the modulus of that is less than a third. When we substitute that value of x into this expression, we get 0.91 to the power 3 over 2 is approximately equal to this. And when we evaluate that, we get this, which is our approximation to 0.91 to the power 3 over 2. Now we've got to find an approximation for the value of 91 to the power 1.5. Well, 91 is the same as 100 times 0.91. Now we've got 0.91, we've got a chance of using the work that we've done already. So that is the same as 100 to the power 3 over 2 times 0.91 to the power 3 over 2. Well, what's 100 to the power 3 over 2? It's the cube of the square root of 100, which is 1,000. So this is 1,000 times that, and we've already worked out what that was. So 1,000 times that is 868 roughly. So that's our approximation for the value of 91 to the power 1.5. Finding the percentage error in the approximation is using the formula estimate minus actual divided by actual times 100%. So you can see a pretty good estimate, less than around about 0.01 of 1%. Okay, so there we are.